Hello there. As the title suggests, we are going to talk about how Java stores integers. Now, we already know that everything in computer is stored as binary, that is, as a combination of zeros and ones. And this applies not only to numbers, it applies to text, images, videos, basically everything. The reason behind it, as in why is everything stored as a combination of zeros and ones, is another topic of discussion altogether. So if you're interested, please let me know and I'll make a different video explaining the reasoning behind everything being stored as a combination of zeros and ones. In this video, however, we will focus our attention to integers. Now, in one of the previous videos, I had talked about data types, where we got to know the 8 primitive types supported by Java and the 4 categories to which they belong. And one of that category was integer. And we got to know that we have got byte, short, int, and long data type in the integer category. Another topic that we had discussed was number system. And we got to know that there are 4 number system: the binary number system, the decimal number system, the octal number system, and the hexadecimal number system. And we had discussed how can we convert a number in one number system to another number system. So if you're already familiar with these topics, great. Please continue watching this video and I'm pretty sure you'll be able to grab everything that I'm going to discuss in a moment. If not, I would recommend getting a good understanding of data types, the number systems, and the conversion of a number from one number system to another so that there's no gaps left in understanding. So with that said and done, let's get started. Let's start off with a bit of a recap. Let's say if we were to represent 42, which is in decimal, to binary, what can we do? Well, we already know what the process is like. We will keep on dividing 42 by 2 and keep on collecting the remainder until and unless we reach a point where the quotient is 0. And once we reach that point, as in once we stop dividing because the quotient is now 0, we will collect the remainder in the reverse order. So assuming that you are already familiar with this, let me quickly get that done. So if we have 42 in decimal, its binary equivalent will be 101010. Now we got this when we solved on a paper using a pen. But how would we do it if we were to use a programming language, which is Java in our case? We already know that we will have to create a variable. Let's name the variable num, and we will have to assign the value to it. So we'll say num is equal to 42. But this statement alone is syntactically incorrect, right? Because we have not specified what the type of num will be. Now, since 42 is an integer, we can use one of the integer data types. So we can go for either byte, short, int, or long. Now, we can also use float or double to store 42, but let's not make it more complicated than it is supposed to be. So let's use one of the data types that fall in the integer category. And we have got 4 options available with us. Now, 42 can easily fit in the range of any of these. We know that the range of byte is minus 128 to 127, and the range of short is minus 32,768 to 32,767, and so on. So we can go for any of these data types. Let's go for byte for now. So if we say byte num is equal to 42, what's going to happen? We know that byte is an 8-bit type, which means we will have 8 bits available to store 42. So let's quickly draw this, and we will have positions starting from the very right, going all the way to the very left. So it will be from 0 to 7. Now we have got 6 digits over here, but we have got 8 spaces. How are we going to put those 6 digits in these 8 spaces? The answer is pretty simple. You start off with the rightmost bit, which is the least significant bit. You put a 0 over here, which is this 0. And you put a 1, then 0, then 1, then 0, then 1. So we have put all the 6 bits over here. Now, what are we going to do with the remaining 2 bits? Since we've got nothing to put, we're going to pad this with 0. So if we say byte num is equal to 42, this is how it will be stored in the memory. Now, I have a question for you. If we had not used byte and we would have used short or int or long instead, what would have happened? So to answer my own question, we know that short is 16-bit type, int is 32, and long is 64-bit type. But we only need 6 bits to represent 42. So what would have happened is the remaining space, that is 10 over here because we only need 6, and 26 over here because we only need 6 again, and 58 over here would have been unused and we would have padded that with 0. So this is how 42 will look like in the memory. Now the next question is, how do we represent a negative number? For example, minus 42, because we know that everything in computer is stored in binary, that is as a combination of zeros and ones. So using just these two digits, how do we represent a negative number? More specifically, how do we denote this minus sign? Let's talk about that. One way to do that is ones complement. Now, ones complement is used to represent negative numbers. Let's see how. If we have 42 in decimal, which is being represented as 00, 10, 10, 10 in binary, assuming that we have used the byte data type, its one complement will be generated this way. All 0 will be converted to 1 and all 1 will be converted to 0. So basically we are just inverting the bits. So 001010, which is for 42, will become 11010101 for minus 42. So this is how simple it is. For 42, we will have 001010, assuming we have used the byte type. For minus 42, it will be 11010101. Now, that question that I had initially asked as to how do we denote this minus still remains. So to answer that, the 1 on the leftmost bit, which is the most significant bit, denotes negative. So if the MSB or the most significant bit is 0, it means it is a positive number. And if it is 1, it means it is a negative number. So is this how Java represents negative numbers? Well, no. Java uses something called 2's complement. And I'll get to that in a moment. But before that, let me tell you why Java does not use 1's complement. So you see, what's happening in 1's complement is, if we have got 0, we change that to 1. And if we have got 1, we change that to 0. So let's take this example. Let's say we have to represent 0 in decimal to binary. And let's say we are using the byte data type. So how will it look like? It will look like 00000000, right? Now, what if we have to go for minus 0? Well, we know minus 0 is 0, but using the logic of 1's complement, minus 0 will be represented as 11, 11, 11, 11, right? So you see, the same number, that is 0, has got two different representation. And this is a problem, right? Because every application will have to take this into consideration. Now, there are more limitations of using 1's complement to represent negative numbers, but I'm not going to discuss that in this video because I want to stick to the main topic that we had started off with, which is how Java stores integers. However, I will have a video later on where I'll talk about why Java uses 2's complement and why not 1's complement. Well, one of the reasons is this, of course, but there are other reasons as well. So coming back to the topic, we know that we have got something called 1's complement, which we can use to represent negative numbers. But we also know that it has got some limitations, one of which is this. And that is why Java goes for 2's complement. So now let's talk about what 2's complement is. So for 2's complement, what do we do is, we first of all find 1's complement and then we add 1 to it. So going by this logic, we know that 42 in decimal can be represented as 00101010, assuming we have taken the byte data type. So let's quickly write that down here. 00101010. Now, this is how minus 42 will be represented in Java. We will first of all find the 1's complement. Now, we already know how to find 1's complement. Find the binary representation of 42, which we know is this. Then change all the zeros to ones and all the ones to zeros, and you will get the 1's complement. So 1's complement will be 11 because we have double zeros over here, and then 01 because we have 10 over here, and then 0101 because we have 1010 over here. So this is 1's complement. Now the next step is to add 1. So let's do that. Now, if you're not familiar with binary addition, which is what we're going to do now, I've covered that in one of the previous videos. I've put the link to that video in the card, which is popping up right now. If you want to understand how binary addition is done, please watch that video. So continuing, what we will have to do is we will have to add 1 to the 1's complement of 42. So we have 1 and 1. Now, if we add 1 and 1, we get 0 with a carry over of 1. Now we have got 1 and 0 to be added. 1 and 0 is 1. Now over here we've got nothing, so we'll just put the same bits down over here. So we will have 1, then 0, then 1, then 0, then 1, and then 1. So the 2's complement of 42 will be 1, 1, 0, 1, 0, 1, 1, 0. And like we had discussed in 1's complement, that 1 being present in the most significant bit denotes that this is a negative number. The same thing holds for 2's complement as well. So if you see, we have got 1, 1, 0, 1, 0, 1, 1, 0. And we've got 1 in the most significant bit. And this denotes that this is a negative number, which in our case is minus 42. So this is how simple it is. 42 or any positive number is converted to its binary equivalent. And depending on the data type that we are using, we will get to know how Java is representing it internally. For a negative number, the process is different. We first of all find the ones complement, and then we add 1 to it to get how Java would be storing a negative number. In our case, that number was minus 42, and we found out the ones complement of its positive counterpart, which is 42, and then we added 1, and we got this, which is how Java will represent minus 42. Now, the next question that might be coming to your mind is, if you have this, and if you have to find out which number in the decimal number system is this representing, the process would be pretty simple, right? Because we have 0 in the most significant bit. We know for sure that this is a positive number. And what we can do is we can convert this to decimal, and it will be pretty simple, right? So it will be 2 to the power 1, 2, then 2 to the power 3, 8, and 2 to the power 5, which is 32. And if we add that, we go for 32 plus 8 plus 2, we will get 42, which is the original number. But what about this? Can we apply the same logic to find which number in the decimal number system is this representing? Well, let's try it out and see for ourselves. We have 1, 1, 0, 1, 0, 1, 1, 0. Now, the MSB has got 1, so this is a negative number. So let's focus our attention to the remaining 7 bits. So what do we have is, we have got 0 at the 0th position, then 1 at 1 position, another 1 at 2 position, then 0 at 3, 1 at 4, 0 at 5, and then 1 at 6. So if we apply the same logic, we'll get 2 to the power 6 plus 2 to the power 4 plus 2 to the power 2 plus 2 to the power 1. And 2 to the power 6 is 64. 2 to the power 4 would be 16. 2 to the power 2 is 4. And 2 to the power 1 is 2. And we have 64 plus 16, 80, plus 4 is 84, plus 2 is 86, which is clearly not the number that we had used. We had used minus 42, right? So how do we get minus 42 starting from 1101, 0110? So to decode, the process is pretty simple. First of all, invert all the bits. So if we invert all the bits, what are we going to get is, we'll get 0, another 0, 1, then 0, then 1, 0, 0, 1, 1, 0, 0, 1. This is the first step. The second step is adding 1 to the inverted bits. So we'll go for another binary addition. We'll have 0010, 1001, and we will add 1 to it. So 1 and 1 is 0 with a carryover of 1. Then we will have 1 and 0, which is 1. Then we will have 0 and then 1 and then 0, 1, 0, 0. Now this must be looking familiar, right? We have 00, 10, 10, 10, which we know is the binary equivalent of 42. So what do we have? We have 42. And since we started off with this, where we had 1 in the most significant bit, we know that this was a negative number. So we will put minus. And this is how we can decode 2's complement to find which number in the decimal number system will this be representing. So this is how 42 is represented in memory, and this is how minus 42 is represented in memory when we store it in a variable in Java. And this brings us to the end of the discussion. Summarizing, we got to know how Java stores integer values, and we understood how it represents the positive integer, which is just by converting its decimal equivalent to its binary equivalent and taking the data type into consideration. And we also got to know how it represents negative integer, which it does by, first of all, converting the positive counterpart of the said negative integer to its binary equivalent, and then finding one's complement of that, and then by adding 1 to it. So I hope I've been able to teach you something new and useful. If you have any suggestions, feedback, or queries, feel free to put them in the comments. Thank you so much for watching, and I'll see you in the next one.